Oh, well, sine trig.
Alrighty. So on page 46, we're going to get to these limits by hand. And in order to accomplish these, we have to use the two limit, like the special trig limits that we discussed yesterday. Those are the ones that we were analyzing with the table. We kind of mentioned how we can't solve those by hand because we can't factor, we can't use conjugates, we can't use fraction work, we can't do expansion. But yet, when we looked at a table, the limit existed somehow. Okay, so let's go ahead at the top. We're going to refresh our memory on those two limits, and we're going to use them today to help us with these kind of more involved trig limits. Okay, so maybe take a look on the few pages we did yesterday. What is one of those special trig limits we got to know? What does the x value approach, and what is the function that we're using? Can we identify either of those pieces? Yeah?
X approaches 0.
X approaches 0 for both of them, actually. Okay, so the x must be approaching 0. If the x value or variable is not approaching 0, these limits we discussed might not be relevant. Okay, so we must be approaching 0. What about either of the two functions? Can we find them? I think we wrote them at the bottom of the previous page. The trig limits we gotta know. Good, Braden?
Sine of c times theta over c times theta.
Okay. So maybe instead of x, we'll use theta here, whatever letter or symbol you want to use as your variable. Okay, so that's one of them we got to know. And then what about the other one? One of them's a sine function, the other one's a cosine function. Good, Dan?
1 minus cosine theta over theta equals 0.
Okay. You might also have the c's in there as well. So I'm going to put them in there just to show that they can be the same. But if the c value is 1, then theta over theta would work as well. Okay, so we got to know those two. We doing okay? All right, so let's go ahead and tackle our first trig limit here. What do we always do first for limits? Substitute, okay? I don't care how many shortcuts or techniques you know. Always try substitution first. So we have e to the 0 times cosine of 0 all over 4. What's e to the 0? 1. Cosine of 0? You gotta know your unit circle. 1, okay, 0 is the starting point all the way to the right on the unit circle. So it looks like our limit is 1/4. Yay! No factoring necessary. No trig limit necessary. Okay, always try substitution first. Don't get too far ahead of yourself. Okay, so let's go ahead and try number 2. Direct substitution.
No.
Let's see, sine of 0 over 0. Ooh, that over 0 is kind of scaring me already, right? Sine of 0 is 0. All right, so we have a hole. So we know the limit exists. Okay, the point doesn't, but the limit exists. That means we're going to have to kind of work our way around this. So we can think of factoring, we can think of conjugates, we can think of fraction work, expansion, all that stuff. But since this is a trig limit, maybe we can use one of those two at the top. What are you thinking, Dan?
The first one, sine c.
Okay.
C.
All right, so notice how this function we're working with kind of fits this first trig limit, and we are approaching 0, right? That's kind of a stipulation. Okay, we have to be approaching 0 in order to use this. Now the issue is, notice how the c value up top is 4, right? And the value down below is 1. Those don't match, correct? We need them to be exactly the same in order to use this limit. What did we find out from yesterday that these limits equaled? Go ahead, Dan.
1.
This one was 1,
0.
and this one was 0. Okay. So let's think about this. We cannot change the 4 because technically, I know they didn't write it, but that 4 should be in parentheses. Okay, it's the value inside of a trig function. It's kind of being held captive. Okay, so that 4 we cannot change. But if we have to have these coefficients matching each other, we need to somehow put a 4 in the denominator, right, in order for them to be the same, in order to match. So how do you think we're going to put a 4 in the denominator? What can we do? Yeah?
Actually,
No? Let's see, if I multiply the denominator by 4, wouldn't that make this look like a 4c, or sorry, a 4 theta, right? But we're dealing with a fraction. So if I multiply the bottom by 4, what else do you have to do? You got to multiply the top by 4. So essentially, we're changing the way the equation looks by simply multiplying the top and bottom by 4. Remember, the 4 inside the parentheses does not change. It's being held captive. So when you multiply the top by 4, that 4 has to go out front. Okay? So can we now visualize that what we have here, sine of 4 theta over 4 theta, doesn't that match our trig limit? Okay? So what do we know that this portion should be? It should be 1. So notice what we're left with. We're left with the 4 that was out front times the 1 from the limit, using that trig limit as kind of an easy shortcut. So our overall limit is just 4. We're going to somehow make our trig equations look like either the sine limit or the cosine limit. That way we can easily substitute in either 1 or 0. Do we see how we did that? Okay, so we may have to do a little multiplying to get there, but we're still going to be able to get there. Okay? They are excited. Can you shut that door for me? Okay, let's try and take a look at the next one. We are approaching 0, which is nice. Direct substitution should always be our best bet. But notice how we're going to get sine of 0 over 0, which is a whole again. Okay, so direct substitution not really leading us anywhere. So let's take a look at our limit. It's a trig limit, so maybe we can use one of the shortcuts, okay, at the top. Which one do you think we're going to utilize here? Does it look like the sine limit or the cosine limit? Probably the sine limit. Okay, so again, that 2 cannot be changed. It technically should be in parentheses, but sometimes we don't write those. But I need a 2 in the denominator, right? I need that c value of 2. So if I'm going to multiply the bottom by 2, I need to also multiply the top by 2. So we have 2 sine of 2x all right, now down below we have 3x times 2, but do you realize how all that stuff's being multiplied together? And when you multiply, order doesn't really matter. So can't I technically do this as well? Right? Instead of 3x times 2, I can do 3 times 2x. Order doesn't really matter when you multiply. So let's take a look at our trig limit. We have sine of 2x over 2x. What should that limit value be? 1, right? Based off of our little shortcut. So it looks like we're left with 2/3 times 1, which is just 2/3. We doing okay? Do you guys think you can try number 4? Okay, give it a shot. Always try direct substitution first. If it's a no-go, maybe try a trig limit. At least for this section, we'll try trig limits. We get 10/3. Working out? Awesome. All right. Let's go ahead and try the one at the bottom. Okay, direct substitution. Let's try to plug in 0. All right, that 0 on the bottom is already scaring me. Okay, so we know it's either going to be a whole or an asymptote. If it's a whole, we know we have a little bit more work to do. If it's an asymptote, we can simply say does not exist because notice how we'd be approaching 0 from both sides, and the limit doesn't exist at an asymptote. Okay, the left and right sides exist individually because you can check if it's going up or going down, but an overall limit never exists at an asymptote. Tangent of 0, can we figure that one out? If we go to the unit circle, go to the beginning 0 location, do our little division. That ordered pair.
0 over 1.
Right. So we have 0 over 1, which is 0. So we have a whole. Okay, we got to get around that somehow. Maybe we can change this equation into something else. I think we saw a little bit of those yesterday, how we can rewrite these trig functions. So what do you feel like doing to rewrite it? Go ahead, Dan.
Sine over cosine.
Okay, so we have sine theta over cosine theta. That's the same as tangent. But notice how we're still dividing by theta. We have 2 fractions going on. Let's try to change that into 1 fraction. Yeah?
If you put cosine in the top and bottom, the cosine in the top cancel out the cosine in the bottom, you would just get sine over theta, and then the bottom would be cosine, and you'd be able to do the sine.
Okay, so you want to multiply cosine of theta up here
Yep.
and cosine of theta down here. Okay, that's one thing you could do. You could multiply cosine over cosine because that would get rid of this denominator. Some of you may have thought of bringing this up and multiplying by the reciprocal. Okay, you could do that. So we would have sine times 1 over cosine theta times theta. Either way, it's still going to work out. Okay, so we're going to have sine theta over theta cosine theta. You can't multiply the thetas together. Again, there technically should be a parenthesis around that theta holding it captive. Okay, you can't do anything to it. So this theta is going to be out front as a coefficient. Okay, so now we have it to 1 fraction. Can we maybe use anything else to help us simplify it? Because if I try to plug in 0 again, I'm going to get sine of 0, which is 0, and notice how this first theta would be 0, canceling out that cosine. I still have that whole. We need to recognize something else. Yeah?
If you multiply both things by cosine theta, you'll have a theta in the bottom and your sine at the top.
What do you mean, like do another cosine times cosine up here?
Because would that cancel out the bottom one?
No, because if you multiply cosine up top and bottom, you'd be having a cosine squared down below. Okay?
Yes, 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 yes.
Yeah. Do we see either one of the trig limits from the top of the page showing up? Perhaps? Let's see. Oh, yeah. Isn't the C value in front of that theta 1? And do we have a 1 theta down below? Right here, right? So this guy is approaching 1, right? Okay, we were used to the C value being something different in the other examples, for instance, 2 and number 3 and 5 and number 4. Okay, but we can also have a C value of 1, just means you don't have any coefficients out there. So it looks like we're left with 1 over cosine, because we still have that cosine in the denominator. Let's try substitution now. Cosine of 0, looking at that point again, looks like we got 1, right? Okay. So it's just going to be a lot of rewriting, a lot of figuring, maybe using those trig limits to help you out. Okay, just don't get frustrated. Just keep trying something else. All right, let's go ahead and check out some more. We got 6 going on here. direct substitution. Let's try it first. 2 minus 2 cosine of 0 squared all over 0. Okay, again, that 0 on the bottom's kind of scaring me right now. Let's see what we get up top. What is cosine of 0? Your beginning point? It's 1. Okay, 1 squared is still 1. So 2 minus 2, we got 0. So we got a whole. All right, now I know they're not up here, so I'm going to go ahead and write them again. Our little trig limit shortcuts. Okay, so when we take a look at this trig function we're working with here, we have a whole, so the limit exists. That means we should be able to rewrite it somehow to get a number as our answer. Taking a look at this equation, notice how it kind of looks like what's going on here. Maybe, okay, but let's not get too far ahead of ourselves. What do you feel like doing?
Couldn't you factor that 2 minus 2 cosine and get a
Okay.
1 in 2 in front and get a 1 minus 1?
Sure. All right, so let's take a 2 out of the top. Okay, factoring is one of our techniques. So we'd have 1 minus cosine squared all over theta. Okay, now notice how we do have a 1 minus cosine, right? But this is a cosine squared, not just simply 1 minus cosine like it is in the limit. Okay, so it's not matching this one exactly just yet. Let's not force it to match it. Okay, maybe eventually it would end up looking like this one. We don't know. Okay, don't force anything. Let the math kind of guide you. I'm hoping like something's going off here that we realize. Yeah.
Couldn't you factor that again?
How?
1 plus 1 minus.
Yes, okay, but I'm wondering where that's going to take us.
Because then that 1 minus cosine theta over theta wouldn't that equal 1?
Would equal what?
Wouldn't the 1 minus cosine theta over theta equal 1 now?
It would equal
0.
0. There we go. Okay, so we can factor it even further, right? Instead of pulling out the 2 like we did before, notice how we have a difference of squares, right? Okay, so if we identify, notice how the C values match again. We have a C value of 1 and 1 down below, correct? Okay, so this portion of our limit is going towards 0. So if we have 2 times 0 times 1 plus cosine theta, all the other stuff that's left, what's our limit approaching? 0. All right. So yes, you could factor that further. I'm curious if someone saw something different. 1 minus cosine squared, yeah.
Sine squared?
Is that what you're going to say too? Perfect. Okay, you don't have to write this down. I just want to show you how you would get the same answer if you chose a different path. Okay, so instead of 1 minus cosine squared, we could have used that identity, okay, like the mother lode of all identities yesterday, and we would get that, right? But if we have sine squared, that technically means we have 2 of them, correct? Right? Okay, so if I take one of those sines, and notice how it matches with the theta down below, because we have those C values of 1, wouldn't that go to 1? So we're left with 2 sine of theta times 1. If I did direct substitution, what's sine of 0? 0. You'd get the same thing. Okay, so like I was telling you, don't force it to make it look like this. Okay, eventually you could, but notice how using that identity then changed it into this one. Okay, so don't force it. Just try to keep working with the math. You have options in some cases, but eventually you should get the same thing. Okay, so for those of you that saw the identity, it would still work out. Okay, let's go ahead and try 7. Direct substitution. Plug in 0. 1 minus cosine of 0, which is 1, plus sine of 0, which is 0, all over 0. We get that lovely whole again. Okay, so there should be something else that we can do to figure out this limit. What do you think? Yeah.
If you were to take the 1 minus cosine theta
Uh-huh.
and have it over theta and then move that plus down to the middle because it's a common denominator, so you separate the fractions.
Okay, we're going to break some hearts. Okay, sometimes I think my kids, I think I told you that last year, or maybe you've heard of that before from different math teachers. I don't want to get to, I mean, it's going to make you guys laugh anyway, and we're all adults in here, right? Okay. Oh. That's not what you think it is, okay? Single term denominator, okay? You see how we have one thing in the denominator? We can use that single term denominator, okay, and break up the numerator, okay? So we could make it look like 1 over theta minus cosine theta over theta plus sine of 2 theta over theta. Okay, you could break it up as such. But do you notice how it would be more beneficial to keep the 1 minus cosine theta together? Because wouldn't that match our trig limit? Okay, so you could break it up like that, but we're going to keep those two terms in the numerator together to help us. Okay, so STD, single term denominator. Sometimes I call it breaking hearts, because let's face it, if you have an STD, you're going to break someone's heart. You can break up that fraction. Okay, we're all adults, right?
Legally.
Legally, some of us maybe. Okay? All right, so here we are rewriting our limit, okay, because we have a single term denominator. You can break up that fraction. Let's go ahead and see what we have here. If we were to approach 0, what would this limit eventually approach? Yeah, that would approach 0, okay? What about our second limit over here? Yeah?
You need to find the C for that.
We got to get our C's to match, okay? Notice how the C up top is 2, and we can't change that one. Yeah.
If you were to multiply by 2 over 2,
Yep.
then the 0 isn't affected because it's 0, and you would get your number that you're looking for, your identity, which would become 0 plus 2.
Perfect. Okay. So we have this other trig function we can use now that our C values match, and that's going to approach 1. So we kind of got to merge all of these different limit values together. We have the 0 and then plus the second limit's giving us a 2 times 1 left over, so it looks like our overall limit would be 2. Okay, so a little bit tricky there. If you have a single term denominator, okay, STD, you could break up those multiple pieces in the numerator. Notice how number 6, though, also has a single term denominator, right? But we didn't necessarily have to break it up. Okay, I'm not saying you have to do that every single time. It's just... oh, gentlemen. It's just, I can't even focus anymore after that. It's just you have to become familiar, okay, that there are multiple techniques, there are multiple ways, and you're just going to have to keep chugging away until something works, okay? I can't tell you exactly what to do for every single problem. I can give you the tools, but it's up to you to use them. Okay? Let's go ahead and try 8. Do you feel like plugging in 0? I don't even know, I mean, I know what cosecant of 0 is off the top of my head, but you guys probably don't. You can probably figure it out. Oh.
Probably either 0 or undefined.
Probably 0 or undefined, one of those two, okay? So maybe let's go ahead and rewrite this somehow to make it in terms of trig functions that we're more familiar with, like maybe sine and cosine or tangent. What do you want to do?
Turn the cosecant into 1 over sine.
Okay, so for every cosecant, let's go ahead and change it into 1 over sine. All right. We're starting to get some fractions here, so we may have to use some fraction properties or techniques to help us out. Yeah.
With this single term denominator, you can separate them again and get a 1, let's say 1 over theta, 1 over sine.
Ooh, okay, so let's go ahead and check this out here. I'm going to go ahead and write theta over sine plus 1, because we can simplify or rewrite the numerator that way. And then down below, we have a theta over sine as well. Okay? Notice how we have a single term denominator. We're not adding anything together, we're not subtracting anything together. We have one term. That term happens to be a fraction, okay, but nonetheless, it's still a term. It would be no different if we had 1/2 down there. Okay, that's still one term, one number. So what we could do is break apart, break some hearts, okay, break apart that fraction. So what's theta over sine divided by theta over sine? 1, right? Okay. What about 1 over theta over sine? What's going to happen there? 1 divided by a fraction? Yeah?
Is that, so it would be theta over sine, right? No. 1 over theta over sine.
It would actually flip, sine of theta over theta. If you have
Yes.
like 1 over 1/2, you could bring up the 1/2 and multiply by 2 over 1.
Right.
Yep.
Yes, yes.
So it becomes 2. Okay, the reciprocal of that denominator. Okay, so let's go ahead and check out our limit. If we tried to plug in 0, at least for the trig portion, we'd get 0 over 0, which doesn't help us, but this should look familiar. Sine of theta over theta approaches 1. So it's 2. Our limit's 2. Yep. All right, let's try 9. Direct substitution. Sine of 0 is 0 minus sine of 0 cosine 0, which is still going to be 0, all over 0. We have a lovely hole. So we have to work around it. What do you feel like doing? There's a bunch of different things. Let's see, we have a single term denominator, so if you wanted to break them up, you could. Okay. Notice how both terms in the numerator have a sign in common, so if you wanted to factor out one of the signs, you could. Okay, it all depends on what you see first and what you feel comfortable with doing. Do we want to go the breaking hearts route? Do we want to go the factoring route? Do we want to try both and hopefully we get the same answer both ways? What do you guys feel like doing?
Factor.
You want to try to factor? Okay. Let's go ahead and take out a sign. So we're left with 1 minus cosine. Okay. Technically, that's over x squared, correct? But isn't x squared x times x, right? Do you notice anything that we can use to our advantage?
Yes.
Yes, some limits, right? Notice how we have a sine of x over x. The c's match. So that would be approaching 1. And the other one happens to be the other limit, right? Which is 0. So we're left with 1 times 0, which is 0. There we go. Okay. If you went the breaking hearts route, okay, you still would have got 0. You just might have had to use some different steps, but it would still work the same way. Okay, same result in the end. We doing okay? Okay, a lot of reworking, but just remember we got to know these two trig limits, because notice how we use those a lot in these problems. Okay, we have to know those. I'm not going to give them to you. All right. I know we still have a few minutes left, but we'll stop there for today. And if you want to start on some of the homework problems for this section, might not be a bad idea. Yeah. Once.